Out in an open field, a tower turns, slowly, patiently. 3 long blades trace a wide circle against the sky, and far away, a single light switches on. Between that breeze and that bulb lies a quiet chain of machines. No fuel, no flame. Just moving air, caught and turned into something you can use. Today we slice a wind turbine open, layer by layer, and follow the energy from the first gust all the way to the grid. Start with the wind itself. Air has mass, and moving air carries energy, the same push you feel against your hand from a fast car window. A turbine's only job is to steal a little of that motion. It cannot take all of it. If it stopped the wind completely, the air would simply pile up and flow around the blades instead. So it slows the breeze just enough, skimming energy from the stream while letting most of the air pass on through. Look closely at a single blade. It is not a flat paddle, it is a wing. Curved on one side, flatter on the other, just like an airplane's. As wind flows past, it travels farther over the curved face and speeds up, dropping the pressure there. Higher pressure underneath, lower pressure above, and that difference becomes lift. The same force that holds a jet in the sky here tugs the blade sideways around its circle, turning a steady push into spin. The 3 blades meet at a central hub, and together they form the rotor. It turns slowly, often just 10 to 20 times a minute, lazy enough to count by eye. But each blade is enormous, sometimes longer than a passenger jet's wing, so even that gentle rotation carries tremendous force. The tips, meanwhile, are slicing through the air far faster than they look, well over 100 miles an hour, slow at the center, swift at the edge. Behind the rotor sits a long steel box called the nacelle, perched at the very top of the tower. Think of it as the engine room, bolted nearly 100 meters up in the air. Inside, arranged in a line, sit the machines that do the real work: a shaft, a gearbox, and a generator. A technician can stand within this box, wind humming through the walls, and walk the whole chain of parts from the spinning blades to the cable heading down. The hub connects to a thick steel rod called the low-speed shaft. It turns at exactly the pace of the blades, that same lazy 10 to 20 turns a minute. This slow, heavy rotation is rich in force, but poor in speed, and that is a problem. A generator wants to spin fast to make electricity well, so the turbine faces a trade. It has enormous turning power, but far too few rotations. The next part exists only to fix that. Enter the gearbox. Inside sits a clever nest of toothed wheels, a small gear driving a large one, then chains of them in series. By meshing a big wheel against a small wheel, the box trades turning force for turning speed. The slow shaft creeps in at roughly 20 turns a minute. The shaft leaving the far side races out at well over 1,000. The same energy, simply repackaged. Less muscle, far more spin, exactly what the generator craves. That fast shaft drives the generator, the heart of the whole machine. Inside are just 2 simple things: magnets and coils of copper wire. One part sits perfectly still, the other spins. As the shaft whirls the magnets past the windings, round and round 1,000 times a minute, something invisible begins to stir inside the copper. No fuel burns here. The motion alone is enough. This is spinning metal, sitting right on the edge of becoming electricity. Here is the quiet miracle, discovered by Michael Faraday. A moving magnet pushes on the electrons inside a nearby wire. Sweep a magnetic field past copper, and those electrons lurch into motion, a current born from nothing but movement. As the magnets flip past, north then south, the current reverses too, sloshing back and forth. That back and forth flow is alternating current, written out AC, the very same kind that already hums in the wires of your home. But raw turbine current is messy. Its rhythm wanders as the wind gusts and fades. So it is first cleaned and steadied by electronics, then sent through a transformer. The transformer trades low voltage for very high voltage, because high voltage can travel long distances without wasting much of itself as heat. From the tower's base, the tamed power flows out into the grid, joining electricity from 1,000 other sources, indistinguishable now, racing together toward distant towns. One problem still remains: wind shifts. A sensor on top of the nacelle constantly reads the wind's direction, and motors slowly swing the whole top of the tower around to face it. Engineers call this yaw. Each blade can also twist along its length, tilting to grab more wind on a calm day, or to spill it safely in a storm. Together, these small adjustments keep the turbine aimed, efficient and protected, hour after hour, as the weather turns around it. So trace it once more, end to end. Moving air pushes on wing-shaped blades, and lift turns them into spin. The blades drive the rotor and the slow shaft. The gearbox trades force for speed, racing a second shaft into the generator. There, spinning magnets sweep past copper coils, and induction quietly wakes a current. Electronics steady it, a transformer lifts its voltage, and yaw keeps the whole tower facing the breeze. Wind goes in, electricity comes out. Next time you pass a turbine on a distant hill, take a moment to watch it turn. That slow, patient circle is a whole chain of machines, quietly handing the wind's energy from blade to gear to coil, down a line until it reaches a wire in your wall. No fuel, no flame, just moving air, caught and kept. We sliced one open today, top to bottom. Thanks for watching the Cutaway, and we'll see you at the next one.